Over the next two sections, we will review and explore a little bit more about a function. Before we define what a function is, first we must think about a simple relationship between two variables. Because we're dealing with two variables, the set of variables can be defined by the domain and the range. The domain is the set containing all inputs, or on an XY coordinate grid, these are the X values, and we can also define this as the independent variable. The range is the set containing all the outputs, or the Y values, and we refer to this as the dependent variable. Taking a look at this graph, as you can see, we have our x-axis, which is defined by time, and our y-axis, which is defined by distance from water. So the domain are any values that fall on this line that represent our x values. So notice our very first x value is 0, and it increases as the graph goes up. And our final x value is 12. So we actually write this as an inequality stating 0 is less than or equal to x is less than or equal to 12. So this shows you that x falls between and includes the values of 0 and 12. We can't include any values outside of those numbers. So for example, we see the number 4 is an input. 4 does fall in between 0 and 12. Now when we're looking at the range, we want to identify with the y-axis, since that is the set containing all of the outputs. So in this case, just like the domain, the range starts at a y value of 0. So we would define this as 0 is less than or equal to y is less than or equal to, well, notice this is these are the highest y values right here, and that corresponds to a y value of 11. So the range only goes from 0 to 11 and includes anything in between. The above graph is considered a function because it is a relationship where each input has only one output. What I mean by this is for every second in time, there is only one possible distance from the water. And because of that, this is defined as a function. So next, we're going to take a look at times where a relationship may be a function or it may not be a function. So looking at this table, we have our domain and our range, so we can actually define that first. At this point, I'm not sure if the domain includes values between these numbers, so I can simply list the numbers themselves. So my domain is 5, 6, 7, and 9. And I use the braces as a way to group the numbers together. And then my range is simply the number 10. That is the only output that I see included. Now we must ask ourselves, does each input have only one output? So an input of 5 has one single output of 10. An input of 6 has one single output of 10. Input of 7 has one single output. Input of 9 has one single output. So I can answer this question with a yes. Each input has only one output. And you might be wondering, but they're all an output of 10. That is absolutely okay. As long as the inputs only have one output, they can all be the same. In this graph, once again, each input only has one output. As we follow this line, notice all of these inputs, -2, -3, 0, 1, 2, 3. and the numbers in between only map to one y value. So that means that this would be considered a function as well. Now the domain in this graph is similar to what we saw up here, since we would consider this a continuous function. So all of the numbers in between our whole numbers are included. So we want to use an inequality again. So notice our first x value is -2. However, because there is an open dot, that actually indicates that -2 is not truly included as an input. And then as we go across the x-axis, all of these x values do have outputs, and it stops when x gets to 3. So we say x is less than or equal to 3. Now for our range, notice our lowest y value is -1. So I'm looking at the y-axis right here. That's the lowest point on the y-axis, or that corresponds to the y-axis. And it starts at -1, but it does not include -1. So once again, I don't want the equal to, I just want less than. And I'm using y since this is the range. And then the greatest y value also happens to be 3. So less than or equal to 3, and that is the range of this function. In this next section, we can take a look and use an equation to help us produce values for our function. So the equation itself, notice, involves two variables, x and y. We can use values for x to determine corresponding values of y. So to do that, first we take a look at our domain. So our first x value is 2. To determine the corresponding y value, I must, not to confuse that with a 0, that's a circle, I must substitute 2 in for x. So notice over here I've written the equation. I'm replacing x with 2, and then I can simplify this to figure out my y value. So 1/2 times 2 is 1, plus 7 gives us an output of 8. So one solution to this equation is the ordered pair 2, 8. And we can do this for each number in our domain. So I also have 6, 10, and 12. So I'm going to use this same process to determine the corresponding outputs for these inputs of x. So when x is 6, my output is a y value of 10. When x is 10, my output is a y value of 12. And when my input is 12, my output is a y value of 13. So I can fill those in my table. And then I would state my range as these 4 values that are written in purple, since those represent my y values. And since it's just 4 individual numbers, I can just list them as is instead of writing an inequality. Next, we can actually use a table and write an equation that represents the relationship or the function. So here we're actually looking for some sort of pattern. How can we take our input and apply some sort of mathematical operations to produce our output? But for this to work, it has to be consistent for each pair of inputs and outputs. So in my first set, I have the input of 4 and an output of 8. So one way to get from 4 to 8 is multiplying 2 by 4 So I start with my input, multiply it by 2, and I get my output. But then I have to ask myself, does this work for this pair? So if I multiply 7 by 2, I get an output of 14, which, as you can see, does not work because my output should actually be 11. So this is not my equation. Another way to get from 4 to 8 is to add 4 to my input. So that equals 8, and I try with my next one. My input is 7. If I add 4, I do get an output of 11. And let's see if this works one more time. So my next input is 10. If I add 4, I do get an output of 14. So that must mean if my input is X, that if I add 4, I should get my output of Y. And that right there forms the equation that represents this table. Next, I want you to pause the video to try these out for your own. You will be determining if they are functions and writing the domain and range. Notice for each of them, the domain and range will be an inequality. So it should look something like this, where X is in between something. So you're filling out these blank spots. And then for the range, Y is in between something. So you're once again, filling out these spots. So go ahead and pause the video, try this out, then hit play to see the answers. So this first graph is a function because each input does have one output. Now, looking at the domain, you may have said -1 to 5, and that's because those are the values you see on the graph. However, because of these arrows, it actually indicates that the graph will continue on forever. And since the graph's direction is going outward, that actually means that all of these Y values will be covered. So what we do with that is we state -infinity to +infinity. Now, since these are not actually numbers, we actually need to change these symbols to less than rather than less than or equal to. So now the domain is -infinity is less than X is less than infinity. So this just means that X can be basically any number at all. Now for the range, notice the lowest or smallest Y value is at the number 1. So I'd write 1 here. And once again, because of those arrows, that means it's forever increasing. So it would actually go to +infinity. And once again, we would need to change this symbol to just less than. Looking at the second graph, is this a function? Hopefully you said no, because each input, or we could say some inputs, have more than one output. So for example, this input of X equals 2, notice has an output here, but it also has an output right here. So because of that, this is not a function. It would only be called a relation. However, we can still define the domain and range because it is still a relationship between two variables. So in this case, notice our domain starts at -6. That's our smallest X value. And then our largest X value is 4. For our range, our smallest Y value is -7. And our largest Y value is at +3. So next you should be completing these practice questions, only the ones that are circled. Do the best you can, reference the notes from above, and make sure you are uploading these to Canvas once you take a picture.